is inner product of xx is greater than equal to 0, and it is 0 if and only if x is 0. The second is inner product of xy is equal to inner product of yx. Third, alpha x comma y, that is alpha x comma y, this is comma. And next is x plus z. Shall we start with the first property?
Yes, sir.
To prove, what is to prove? P01, the inner product defined is IPS. Correct? So what is the first step I need to check? Yes. Whether the inner product of f comma f that is positive. Correct? Inner product of comma f that is going to be 0 to 1 f of x the whole, correct? F of x into f of x dx. Yes. What is that? Integral 0 to 1 fx the whole square. Yes. What can I conclude from this? Can you conclude from this that inner product of ff is always greater than 0? And how can you do that? Yes.
Yes, sir. Yeah. F is
How?
continuous and F is positive at some x.
No, f.
Between
I
0.
don't care. I don't know about f. I don't know about f. What is my function here? Do you observe here?
Real number, sir, we get, and square is always positive,
Yes.
non-negative.
That is the function. Here f of x no is not my function. F of x the whole square, the whole thing is my function for me. Correct? Do you agree? Which is a positive thing, which is a positive function. So what can you say about integral of that? What will be the integral? If this is positive, then integral is always
Positive.
greater than 0. Do you agree, everyone? Here f of x is not my function. F of x the whole square is the function for me. Yes. I'll just repeat once again. We want to prove C01 with the inner product defined is IPS, that is inner product space. First thing, first property I need to prove that inner product of ff that should be positive. So what is inner product of f of that is integral 0 to 1 f of x into f of x, which is same as inner product 0 to 1 f of x the whole square dx. But what do we by the previous theorem I have proved something. If my function is non-zero or function is positive, then integral is positive. So here my function is positive. Do you observe? What is function for me? The whole thing is the function, that is f of x the whole square is my new function, which is positive since it is square. So that inner product will be positive. What is the next thing? In this only you are having the next thing, that is if inner product of ff is
0.
0. So I have proved it in the last theorem only, correct? Inner product of f of is 0. That means what? Inner product of f of x the whole square dx is 0, correct? We have proved if and only if condition, correct? That means what? This f of x the whole square should be 0. Do you agree? Which implies f of x is 0. Correct? Everyone, do you
Yes, sir.
agree? Do you follow? Neha, Payal, have you understood the first step?
Yes, sir.
Neha?
Yes, sir.
Okay. Can you quickly check the second one? What is the second property you need to check? Yes.
F of xy equals
Yes, inner product of f and g. See, here the functions are f and g, huh? Not x and y, Shreyas.
yes, sir.
So inner product of
Yeah.
f and g. Do you see that is quite easy to prove? That is just integral 0 to 1 f of x into g of x dx, which I can write it as 0 to 1 g of x into f of x dx, which is same as inner product of gf. Is that clear, everyone?
Yes, sir.
Yes.
Similarly, the third one. What is the third one? Alpha f comma g, which is again integral 0 to 1 alpha f of x into g of x dx, which is same as alpha 0 to 1 f of x into g of x dx, which is same as alpha inner product of fg. Is that clear? And remember one thing, this alpha is a real number. If I take f comma alpha g, then also this is same. Do you agree?
Yes, sir.
Yes, sir.
Yes, good. What is the fourth property? Inner product of f
Distributive property.
plus g comma h, correct? Yes. So what will
Yes,
this
sir.
be? It will be 0 to 1 f plus g of x into h of x dx, which is same as, yes, what is f plus g of x? That is f of x plus g of x. So it will be equal to 0 to 1 f of x into h of x. I'm just multiplying that of x. I hope that is clear to you. G of x into h of x. Correct? And dx. Now we have the property of integration. That is, I can take integration to all the function, all the subsequent function. Do you understand? So this will be 0 to 1 f of x into h of x here dx plus here 0 to 1 g of x into h of x dx. Correct? What is this inner product of fh? What is this inner product of gh? This is what you are supposed to prove, correct?
Yes, sir.
And one more thing, if you want to prove inner product of f comma g plus h, then that also can be proved like this only.
Sir, it is
F comma,
by the commutative property.
yes, because it is commutative, because here you are having just multiplication, correct? Why I am saying all the time this thing, because this may not be true in the case of complex. There may be some definition where this commutative does not hold. So that's why we should always think about, we should check both the sides. Alpha is in first quadrant, alpha is in second quadrant. Addition is in first quadrant, addition is in second quadrant. We should think about it. That's it. Okay. So what is the conclusion? Have we proved all the four properties? So what is the conclusion you make? Hence you can say from
It is a inner product
1,
space.
2, 3, and 4 that C01 with the inner product defined is inner product space. Correct? See, it was just 2-line proof. I did it together with you. We just required one thing. For that, I have already proved it. In the first case, we required here this. If your function is 0, if your integral is 0, can you say what function is 0? So that is only true if my function is positive, and I am having my function is greater than f square is greater than equal to 0. Do you see that? Yes. Yeah. I'll just give you 2 minutes. Go through the proof once again, and we'll go ahead. Go through the proof. Check if you have any doubt or anything.
Sir, for proving this, do we have to prove the previous theorem also? Because we used that.
Yes, yes, you should prove it. If you're using it, you should prove it here. Mostly, actually, that theorem should be included in SYBSc. I'll introduce this in this semester. I'll teach them this property. Since we have not done in SYBC, that's why I'm telling you to prove, to write the proof.
Yes, sir.
Tell me once you are done.
Done, sir.
Good. What about you guys? Payal, Neha, Ritika is also
Done,
there.
sir.
Ritika, why are you late, Ritika? Ritika, can you hear me?
सर नेटवर्क इशू था इसलिए.
Okay. So let us go ahead now. We got the definition of metric. We got the definition of inner product space. What is remaining now? Anybody? Is there something remaining to define yet? Yes. What is norm? If you follow your SYBSc, after inner product, you learn what is norm, correct? Yeah. So let me just define that. So let V be an inner product space given a vector x belongs to V. Okay. We define the norm, or that is called length by norm x. This is the notation, correct? And we read it as norm of x. Okay. As the non-negative square root of inner product xy, inner product of xx. That is, norm of x is defined as square root of inner product of xx. Yeah. Oh, so in the case of if you take a real number and if you take dot product, what do you think? For r, if you take multiplication, then this will be same as, this norm will be same as mod, and you already know that mod x is same as square root of x square. Do you agree? Yes.
Yes, sir.
Good. So let me just tell you the first example. Euclidean space is the first example we should consider. That is the yeah. So what is norm? That is a square root of inner product of xx. Example, Euclidean space you can take. What is Euclidean space? Yes. What is Euclidean space?
Inner product is dot product.
Inner product is dot product, correct? Good. Is that clear to everyone? So if you take x comma y belongs to Rn, what is the inner product of xy defined? How is it defined? How is it defined?
summation of xi yi.
I equal to 1 to n x I y I. Is that clear to everyone? If you don't understand anything, then ask now only, because we are going very slow till now. Is that clear? So what will be the norm here? Norm x, what do you think? Norm x will be square root of inner product of x. And what do you think that would be here? Yes?
X into X.
That is, it will be summation of xi square, correct? I equal to 1 to n. And if you take this n equal to 2, that means in R2. In R2, what is the norm? In R2, you can write is norm x or
Under root x square plus y.
correct. Or let me write the value of x comma y. In R2, it looks like coordinate, correct? So it is root of x square plus y square, correct? Yeah. Do you see it is quite similar to the length and something in the complex used to call it as modulus. This is the length of the vector. Yes, here also this is same. We are just extending the notion of that only. So what is norm? It is called length, or you can read it as norm. And the definition is it is square root of inner product of xx. Is that clear?
Sir, this won't be x square plus y square. This would be x1, x2 plus y1, y2.
No. See, in R2, what is my vector? Stress. This is same as I'm just writing uh, inner product of x. Correct. And this x in R2 looks like x comma y, no?
Yes, sir.
So that is what I have written.
Okay.
If you don't like this, you can write it x1 x2. Correct. Then this will be x1 square x2 square.
Yes, sir. Now it's clear, sir. Yes, sir.
So if I write just x, that means I'm talking about that norm x. But here I'm writing that x as the element in R2, which is coordinates. That's why I have written bracket. Do you see? This is bracket x comma y. Is that clear?
Yes, sir.
Good. Now there are some properties of norm. Let us see. Properties, you should consider that just like in the case of modulus, we have some property, correct? So now we have defined norms. So we have some property, correct? I think I have done all this thing in your TyBsc, but still in this syllabus we are having this thing. So let us learn that. The norm function. What is norm function? Can you define from where to where? Yes. How many vector required to talk about norm? Yes. Do I require two vector, or do I require Cartesian products just like previous one, inner product and metric definition? We require two vectors, correct? But what about
Yes.
norm? Do I require two vectors? Yes. Norm is defined only on one vector, na? Look at that. In the previous slide I have written. What is this? I have defined norm x. So I required only one vector for norm, correct? So norm is defined from V to R, where V is a inner product space. What is inner product space? A space in which inner product is defined, correct? Now, what are the properties of norm? In the norm, you can consider it as mod in the case of R, real number. What are the property you know? The first property, most important property, it should be always positive, correct? What is the first property? Norm x is always greater than equal to 0. For all x belongs to V. Can you prove this? Can somebody prove it quickly?
Yes, sir.
How will you prove, share?
It will be under root x
Inner product.
square of all components of that vector x.
No, no, wait. Shreyas, I am not fixing here my dot product or something. I'm just talking about in general inner product x comma y. V is any inner product space. Okay. I just want to prove this norm x should be always positive.
Sir, inner product is always positive. So
Correct.
root of inner product would be root of positive would be positive, sir.
Inner product we have, but the first property. What is the first property? Inner product of x comma x is always greater than equal to 0. Correct. If you take square root of that, that is also greater than equal to 0. That's it. You understand, everyone? Go back to the first property of inner product space, and in that first property, you are having the second condition also. If inner product is 0, then that value is 0. Here also, I'm having the same thing. Do you agree? So, do I have to prove anything? It follows from the definition only. Is that clear to you?
Yes, sir.
Good. Everyone?
Yes, sir.
Yeah. What about the second one? If you have norm of alpha x, then that would be equal to mod alpha norm x. Can you prove this? Just try to prove in your mind and see whether you can prove it or not. Alpha is a real number. Do you see why this mod came into picture? If you know that, then you can.
Calling you from Kotak Mahindra Bank, and it was Rohit.
Sorry. Yeah. See whether the sharing is now done. Yeah. Can you see the screen? Is there anyone who can prove? Just raise your hand so that I can ask with someone. Anyone who can prove the second one, second property? Can you hear me? Can you prove the second property?
Sir, I have an
cannot.
idea.
Okay. Just keep it with you till now. Let me see anybody else. Payal, Neha, Ritika, do you have any idea for the second
Yes, sir.
property? Yeah, Payal, go on. Tell me what is the
Sir,
idea.
norm of alpha x is equal to under root alpha x1 square plus alpha x2 square. Then we can
We are doing in general, Payal. We are doing in general. So, why square thing and everything? I don't understand that. Why do you require square? Because I just know one thing. I know that norm x is equal to inner product of this square root of this. That is what I know. That's it. I don't care about square
Sir,
root or anything. Because
uh, sir, now I can prove this.
yeah, just wait a minute. Yes, Payal. Do you understand that why there should not be any square or something? Because we are not doing in particular to R or R2. We are doing in general. V is any inner product space. Payal?
Yes, sir.
Yeah, good. And now, do you see the proof now? Now it is quite clear. I have written everything actually. Do you see the proof now?
Yes, sir. It is the norm of it is the inner product of alpha x comma alpha x. So uh, alpha can be put in common. So there will be alpha square under root alpha square.
How can you take alpha common? Is there anything we know? How do you understand that I can take alpha outside from the first coordinate and from the second coordinate also, and there won't be any problem? How do you understand that? Do we have any property or anything in the case of inner product space?
Yes, sir. Definition of the inner product space.
Very good, exactly. The definition, I think second or third property, I'm not sure, third one, maybe. That is inner product of alpha. If it is in first quadrant, I can take it out. If it is in second quadrant, I can take it out. Correct? Good. Is that clear to everyone? Can you see the proof now? It is just one line norm of alpha x. It is same as inner product of alpha x comma alpha x, which is same as inner product of alpha square, inner product of x comma x. Yes. What is that? Mod alpha square root of xx. Do you understand, everyone? Is it clear to you?
Yes, sir.
Good. So these were the two properties, most important property. Yeah. Okay. Now, if I am having length, correct? Can I make unit vector? Can I make a length unit? How can I do that? If you would like to make it unit vector, what is the process to do? Given any vector, it has some length. I would like to make it unit vector. I would like
X
to make the
upon norm
length as
x.
exactly. Do you clear everyone? Is it clear to everyone?
Yes, sir.
Yeah. I'll just write a note maybe. Let us take V as a vector in V. Okay. V is the inner product space. And let me define U equal to V upon norm V. Correct? So what is this U? U is called unit vector. Why it is called unit vector? Because if you take norm U, it is going to be, this is a number for me. I can take it out. Just find what is norm U. That will be norm V upon norm V. That is 1. Do you see? So you can make any vector as unit vector by dividing with its length. Correct?
Yes, sir.
And we call it as unit norm or unit length. We call it as unit norm. I may write it a unit norm. Unit norm means what? Norm of U should be 1. Okay. Now once we are done with this, what is next? If we are having norm, we are having some more properties. The most important is Cauchy-Schwarz inequality. What is this Cauchy-Schwarz inequality?
Summation xy is less than or equal to summation x plus summation y.
Yeah, Shreyas, that summation was because we were considering it into R2 or over R. That's why there was summation. But now we are going to do it in general. Correct? And you will see that this in general part is much easier to that one. Okay? Let V be an IPS, inner product space. Okay? Then we have mod of inner product of x comma y that is less than equal to norm x norm y. Okay, for all x comma y belongs to B. This is what the Cauchy-Schwarz inequality is. This is what you want to prove. Now, in particular, if you take x and y as a real number, then you will see what is that. This will be just mod of xy, that is equal to norm x norm y. If you take over R2, if you take x and y over R2, then try to see what is the relation you will have. If you take Rn, the thing whatever we have proved in your FYBSc, that was for Rn, Cauchy-Schwarz inequality. Is that clear? After proving, we'll get to know. Yes, and when the two are equal, I'll just write the equality holds. If and only if actually, if and only if one of them is scalar multiple of other. Okay, so I would like to prove this. Now we know the definition of inner product. We know the definition of norm. This is what we are supposed to prove. I'll just give you 2 minutes. Think about it. Do you have any idea? Think whatever you want to think. How will you prove? This is what the question is. You know what is the definition of norm x? You know what is the definition of inner product of xy? Try to prove this. And you know one thing, one more thing, you know. If you want to prove something mod x is less than k, what you are supposed to prove actually? Do you know that? In particular, if you want to prove mod x is less than
Minus
k,
k less
which is
than x
exactly
less than.
minus k is less than x is less than k. Correct? So now I have everything. 2 minutes. Think about it. Okay. Yes. Do you have any idea? Anyone? Yes.
Sir, norm x we should write it like more under root inner product of xx, so it would be easy.
Okay, Dan, you wrote it like that. What next?
Then we can do norm of inner product of x comma x plus y. No,
Yes.
no, sir, I'm not getting anything.
Okay, okay, no problem. Try to think. The first easy step you should think about is, can I take some cases? If my x is 0, if my y is 0, if my x is unit vector y is something like that. Can I think like that? Because if one of them is 0, then I think I am easy to prove at least in some cases. Then at least I will be halfway through. I have proved it some people. Correct?
Sir, if one is zero, then both will be zero.
Correct. If any one of them is 0, then do you see the result is true? Do you see the result is true?
Yes, sir.
Good. Now let us do that one. Correct? Norm x or norm y is 0. This is always 0, but either one of them is 0. If my x is 0, y is non-zero, then something like that. Correct? Then the result is true.
Yes, sir.
Okay, good. Now let us take one more case. If x and y are unit vector, if norm x is 1 and norm y is 1. Okay. Yes. And we are going to consider something. Let us see. We are going to consider this x minus y, x minus y. Shreyas, you had an idea a little bit like this only, but if you had thought little bit more, you must have get it. So what is this norm of inner product of x minus y, x minus y? Yes. How can you solve this inner product? Do you know the property? You have some
Distributive
property for
property
inner
two
product.
times.
Yes. And do you know one more thing, that this inner product is always positive by the first property of inner product space? If you are having inner product of x comma x, that is always
Yes,
positive.
sir.
So can I say that this is always greater than 0? Is that okay?
Yes, sir. Sir,
Now if I
x is
apply
not equal to y, right?
x is not equal to
Y.
What is the problem if they are equal?
Then it would be 0.
So that's why I have written greater than equal to 0. Do you see? I'm just not saying
Okay.
strictly 0. There are some cases, correct? Either greater than or 0. It may be 0. I don't care.
Okay, sir.
Yeah. So what next? What should I do next? How to apply inner
Norm of
product?
x comma x minus y minus.
Go slow. Let us go slow. Shreyas, now I would like to use the fourth property of inner product space, correct? What is the fourth property? I can separate them, isn't it?
Yes,
Can
sir.
somebody tell me one by one each step? The first one is yes. This will be, if I take x as it is, this will be x comma x, correct? Plus this will be, you can take x comma minus y, plus this will be minus y comma x, plus this will be minus y comma minus y. Do you agree, everyone? Can I write like this?
Yes, sir.
Yes, sir.
Exactly. Now what do you see this one? This is norm x. And what do you know about this and this? Can I take minus 1 outside? By which property? By, I think, third property of inner product space. And this here also, x and y, they can get interchanged, correct? Do you
Yes, sir.
understand or not? So can I just quickly write it as 2 times inner product of x comma y? And here can I write just as norm y? Just check and tell me. Do you
Sir,
agree with this,
minus.
everyone? Yeah. This should be minus. Yes, good. Do you agree, everyone?
Yes, sir.
Okay. Now, what is norm x and norm y in this case? In this case, what is norm x, norm y?
1.
1, correct. Do you see if I take this minus 2x by this side, I'm done actually. I will just write it. I'm already having 0 is uh, this one. So if I take this minus term here, so I'll be having inner product of x comma y that is less than equal to 1. But what is 1? Can I write it as, which is same as norm x, norm y? Do you see my result is true for this?
Yes, sir.
Everyone, do you agree? If my norm x is 1, norm y is 1, then my result is true. And it is quite easy to prove here. You saw that, correct? Is that clear? Shall we
Yes,
go
sir.
ahead?
Sir, norm 1 we took.
Yeah.
Now other cases.
Yes. This is the first case. You can take this is the second case. Yeah. What are you saying, Shreyas?
No, sir.
Yes,
I
Shreyas,
was
what are you
talking
saying?
about other cases.
Yeah. We are going to do other cases. One more case I can take. See, here I took norm x and norm y as 1. Can I take my inner product of xy as 1? Then let us see what happens. That means let me see the third case. If I'm having inner product of x comma y as 1, mod of x comma y is 1, correct? Then I need to prove something. What do you think I should write? If inner product of x comma y is 1, that means what? What about inner product of x comma y? They are either 1 or minus 1. Correct?
Sir, one, sir. It's positive always.
Yes. No, I'm not solving inner product. I'm just writing mod. I'm breaking the mod. I don't know about inner product yet. And Shreyas, one more thing. That is inner product of x comma y. That is not inner product of x comma x.
Yes, sir.
So inner product can be negative. Can I give you some example where the inner product is negative? Inner product of x
No,
comma
sir, I
x
get.
is always positive. Yes. Okay. What next? What should I do next? Shall we go ahead with the same inequality again? How will you go ahead next? Yes. So you are having two cases. Do you see that? If you are having one, if you are having -1, you have to play like that only. So suppose if this inner product of x comma y is say a -1, let us take. Okay. If this inner product of x comma y is -1, then how will you prove? How will you prove?
Inner product of minus x comma y is 1.
Inner product of minus, you are taking minus
X.
that side, correct?
Yes, sir.
Then
Minus sign we can take inside of inner product.
okay, you are saying this to be the minus x comma y as 1. What next? What next? Good, you are going great. What next?
Norm is 1 then.
Then what? Think about it. If you are having inner product of x comma is -1, can you do this only? Think about this. X minus y, x minus y. What you are having this as norm x minus 2 times inner product of xy plus norm y. Correct? Yes.
So
Yes,
we
sir. We
can
can.
We can, yes.
minus 2 inner product of xy as a plus 2 inner product of minus xy.
What did you say? What did you say? Will you repeat?
Minus 2 inner product of xy we can write as plus 2 inner product of minus xy.
Plus 2 inner product of minus xy. Then what?
Then we can write 1 over there.
Then yes, you got that value as 2. Then next,
Inner product of xy is 1. Oh, sorry.
yes, then inner product of xy is 1. First of all, are you with the point? What do you have? What you are supposed to prove? Are you with that thing? Let us just forget this thing. And what you are supposed to prove? Think about that.
Mod of inner product
If
of
we want
xy
to
is less than or equal to norm x, norm y.
mod of inner product of xy is less than equal to norm x, norm y, correct? Now, if you are given inner product of xy equal to -1, what is the thing you should understand here? That means you want to prove something 1 is less than equal to 1 or -1, whatever you have. 1 is less than equal to norm x, norm y. Correct?
Yes, sir.
Is this true if any one of them is greater than 1? Because you know about norm is always positive, correct? Is this true if you prove any one of them is greater than 1? Yes? Or one more case, if you take x equal to -y, then what do you think here? If you take x equal to -y, what do you think here? This left hand side would
Norm
be,
of x, y.
yes, it will be inner product of -y comma y, that is -1. That means what? Minus of inner product of y equal to -1. That means norm y equal to 1. Correct?
Yes, sir.
Okay. Yes. So can I conclude from that? That is, if x the inner product of xy equal to 1, then either x is equal to -1 or x equal to y. These are the two things. From this, I want to say either this or if it is 1, then I would like to say this. Because if they are something like this, then I'm done actually. I think I should have considered x plus y for this. Instead of considering x minus y, I should have considered x plus y. See, now let me just erase this.
Sir, can't we prove in general? Like there are too many cases.
Yeah, we can prove that in general. Even we can use the second property actually. The second case, what was the second case? We make the vector as unit vector, correct? So we can make any vector as unit vector by dividing. So we can make the help of second one. This one. We have already proved for norm x equal to 1, norm y equal to 1. Correct? We can take the help of this. Something like this. Say if x and y are two non-zero vector. Correct? Then how can you define? Let us define u and v. What is u? X upon norm x. And what is v? Y upon norm y. Correct? And what do you know about u and v? U and v are unit
Norm
vector, and
here is for
we have already proved something for unit vector. Correct? And what is that? We have already proved what we have proved that in this case. See, inner product of x comma y is less than equal to 1. So can I use it here? That is mod of inner product of u comma that is less than equal to 1. Yes. So at the place of u, can I write norm y that is less than equal to 1. What else? Are we done? Do you see that? Can I take 1 upon norm x outside? Can I take 1 upon norm y outside? Yes. Can I take it outside or not? This is a real number, correct?
Yes, sir.
So if I take it outside, I'll send it there. So I'll be having a mod of x comma y that is less than equal to norm x norm y. Do you see? Do you see that?
Yes, sir.
Okay, so that is the proof. We may take the help of that, but I think I should do that case for you. And one more thing is remaining this part. The equality holds if one of them is scalar multiple of other. How will you prove this? This is if and only if. So you should start like that.
Sir, alpha times we get
How will
alpha x equal to alpha times y.
So if let us consider inner product of x comma y is same as norm x norm y, correct? We are going to use the same property whatever we have done till now. So let us take norm x norm y this side, and can I write it? This is if and only if inner product of x upon norm x and y upon norm y. Can I do that? That is equal to 1. Yes. Can I say this?
Sir, mod was there.
Yes. What are you saying? Mod? Yeah, that is not a problem for me. Right hand side is what norm x norm y, na?
Positive. Okay, sir.
Equality. I'm talking about equality. So what next? What can I say about x if inner product of x comma norm x y comma norm y that is equal to 1? What can I say? Can you say that x upon norm x that is equal to y upon norm y? You see why I'm saying this? Because what do you know about x upon norm x? This is a unit vector. And what do you know about y upon norm y? Yes,
Unit vector.
both are unit vector, and you are given that inner product of x comma norm x and y comma norm y that is equal to 1. Can I say that x upon norm x is same as y upon norm y? Because inner product is 1, correct? Inner product is 1 only for the unit vector. That means what x equal to, you can write it as norm x upon norm y into y, which is same as x is scalar multiple of y. Means proved. Do you understand this part from here to here? Yes. Is this clear? Hello.
Yes, sir.
Yeah. Actually, the same thing we are supposed to do there also. Maybe I can write it in the case 5. We have completed everything, but let me do this. suppose I am having x comma y equal to 1, the mod of x comma y equal to 1, then I am having two things, that is either inner product of x comma y is 1 or minus 1, correct? Now let me take if inner product of x comma y is 1, what can you say? What if inner product of x comma y is 1? Yes. From that inequality, can I say something? Actually, I in the previous case I took minus, and that's why the problem was. This is what norm x minus 2 times inner product of xy, correct? And plus norm y. Yes. What can you say? What do I know about norm x and norm y? X minus y. This should be 0. I am going to claim either this is 0. Actually, what is my claim? Let me just tell you. If I consider this, the claim is either inner product of x minus y is 0 or x equal to y. This is the claim if I take inner product of xy equal to 1. So let us consider. If so, I have to take two cases. I have to prove. I have to consider inner product of xy equal to 1. I have to prove either this or this. Either any one of them is true. Can you do that? Think about it. The first part is quite easy, I think. The first part is yes, quite easy. Can you do that? The first part.
Sir, norm x and norm y we have taken one.
Yes.
Have we taken norm x and norm y equal to 1?
No. Norm x, norm y, we have not considered. We have only one condition, that is inner product of x comma y, that is 1. Now I am claiming that if this is true, either my x is equal to y. See, x equal to y, I told you in the previous fourth property I used. If inner product
Sir,
of
we
x
can
y equal
do that since norm x is a real number. Inner product of x by norm x comma y by norm y equals to 1. So we can take norm x 1 by norm x times norm y outside of inner product, then multiply it to 1. So inner product of xy will be norm x times norm y, and inner product of xy equals to 1. Therefore, norm x times norm y equals to 1. So now,
so what may be right what you are saying. You are saying to follow this, correct? X upon y. You want to write 1 as inner product of x upon norm x, correct? And y upon norm y. This is what something you are saying, Shreyas.
yes, sir.
Then what you are taking this 1 upon norm x, 1 upon norm y outside, correct?
Yes.
Then we'll get the inequality x, norm x into norm y, that is equal to 1. and they are equal. Actually, we didn't get inequality. They are equal. Inner product of xy, but the thing is that if x and y, if inner product of x and y is same as inner product of x upon norm x, y upon norm y, then they are unit vector, correct? That means what, this norm x is 1 actually, this norm y is 1, then only they will be same. Do you see that, Shreyas?
Yes, sir.
We have to think something else maybe.
Sir, example we can take.
See, x minus y, no? Inner product of x y is 1, and I'm having this, this will be 2 times. Maybe I'll think about it. No issue. Let us keep hold on the fifth case. Let us revise all the 3 cases first, all the 4 cases. What is the first case? I'm taking any one of them is positive, 0. If x is 0, y is 0, then this is true, result is true. The second case we are taking if norm x is 1 and norm y is 1. I'm taking both as unit vector. Then how did I prove? I prove that 0 is always less than equal to inner product of x minus y, inner product of x minus y by the property of IPS, correct? Then we try to solve that, and what did we get? 0 is less than equal to norm x minus 2 times inner product of xy plus inner product of y, which is same as inner product of x is 1, so that will become 2, and 2 get cancelled. I'll be having inner product of xy that is less than equal to 1, which is same as norm x norm y. Is that clear? Is this part clear to everyone? First and second property, first and second thing, yeah.
Yes, sir.
Yeah. What about the next one? The third case we are taking, if we are having any non-zero vector, can I make it as a unit vector? Yes, I can make it. What is that? U equal to x upon norm x and v equal to y upon norm y. Then we are from the previous case, I'm having mod of inner product of uv that is less than equal to 1. So what is u? X upon norm x. What is v? Y upon norm y. We can take it out, and that's it. Again the result is true. Correct? Yes.
Yes, sir. Sir, the third would be in general.
Yeah, third is in general actually. We can finish the proof till fourth one also. The fourth is compulsory because later on we have asked that if they are equal, then we need to prove that one is scalar multiple of other. Correct? This is the fourth one. Actually, this is the thing I am using in the fifth one. Maybe there is some issue in explaining or something. Because here, do you see? I am proving that inner product will be same as 1. So I have to prove either x is y or x is minus y. So maybe I'll just try to write the proof properly and send it to you. This one, okay? Actually, I just have to prove either x is 1, either x is y or x is minus y. They are a scalar multiple of each other. That is what I am supposed to prove. So till now, you can just ignore this part. I'll send you the proof of this. Till that, the proof is complete till fourth one. I just wanted to do that also. Is that clear? The fourth condition. What is the fourth one? In the statement, it was given the equality holds if one is scalar multiple of other. So till condition 1, 2, 3, I have proved the proof. I have proved it, and the additional part I have done it in the fourth one. Is that clear?
Yes, sir.
Okay. Now there are some more properties of norm. I should mention that since it is mod, so you already know the properties of mod, correct? The norm inner product on a vector space as of satisfy the following. The first property it satisfy norm x is greater than 0. Second, I am writing all this thing because I am going to define it something. And what? Norm x equal to 0 if and only if x is 0. And the next property inner product of alpha x, that is equal to mod alpha norm x, where alpha is a real number. And the third property I am having inner product of x plus y. We have already seen the proof of first and second. Can you prove the third one? Anyone? Can you prove the third property? That is also called triangle inequality. Yes, can you prove it? This is same as whatever you have done in the case of real. You just have to use Cauchy-Schwarz inequality in that. Yes. How will you start? I'll just help you a little bit. You start with inner product of x plus y the whole square. What is that? Inner product of x plus y and x plus y. Is that clear? Can I say this? Yes or no?
Yes, sir.
So what is the right hand side? That will be what? Norm x. It will be norm x the square plus norm y the square plus 2 times inner product xy. Do you agree? Do you agree or not?
Yes, sir.
Yes.
Okay. And by Cauchy-Schwarz inequality, can I write this? Inner product of x and y. Can I write it this as norm of x square plus norm of y square plus 2 times norm x norm y. Can I write it? Am I done? This is same as norm x plus norm y, the whole square. Correct? Do you see the proof, everyone? Taking square root both the side, we are done. Is that clear? Is the proof clear to everyone?
Yes, sir.
I'll just erase it. Okay. Now, if the pair v comma norm is called norm linear space. Or you can write it as NLS. We used to write it in NLS. So whenever I use the word NLS, that means it is non-linear space. And what is the property or how to define non-linear space? If you are having a norm having the above three properties, correct? You maybe I should mention the norm from V to R satisfying above three properties, then we call the pair as NLS, non-linear space. Is that clear? What is inner product space? If you are having a vector space satisfying those four property, then we call this as inner product space, IPS. And if you are having a vector space where norm is defined like this, and we are having it satisfies three properties, then it is called non-linear space. Is that clear?
Yes, sir.
Good. Now one example for non-linear space. Given a non-linear space, how I'm going to write V comma norm. That means I have defined a norm. And how the norm is defined? Say d of x comma y, that is equal to norm of x minus y. Correct? Then prove that D is a metric. Metric on V. Can you prove it? Can you prove this D is a metric on V quickly? What are the things you need to check for the metric?
Greater than 0.
Greater than 0, and that is true because our definition of norm, we know that. Correct?
Yes, sir.
So what do we know? Norm of x minus y is greater than 0, so that means d of x comma y is also greater than 0. What next? What
Comma
next?
sir. D of xy equal to d of yx.
No, before that, in the first property, there are something else. D of x,
It
if
is
d
0
of
if one
x
only.
is 0, then that means norm x minus y is 0. That means what? X equal to y. Do you agree? Correct?
Yes, sir.
Yes. What next? And it is if and only if. And d of xy is same as norm x minus y, which is same as norm y plus x. But you have to prove this property. Huh? I'm just keeping this. Yeah. And what next? What is the third property? What is the third one?
Triangle inequality. D of
Triangle
xz.
inequality. We have already stated in the last slide, correct? So d of xz,
Yes.
what is that? Norm minus z. So I am going to add and subtract x y. So that will be the inner product of x minus y plus y minus z. And I know something. I know that this norm satisfies triangle inequality, correct?
Yes, sir.
So what I can write? I can write this is like equal to norm of x minus y plus norm of y minus z, which is equal to d of x minus y, sorry, x comma y plus d of y comma z. Is that clear? That is what we are supposed to prove, d of xz, that is less than equal to this. So what is your claim? What do you say here? It is metric on V, correct? That means if you define a metric which is equal to norm of x minus y, then that norm x minus y is a metric, correct? Actually, this
Yes,
is
sir.
most famous metric which you use all the time. This metric, this is referred as metric associated with the norm. This metric is called metric associated with the norm. We'll be using it from the next lecture all the time, mostly. We are going to prove some property and all with this only. Now, one homework for you is this. Show that following are norm on Rn. The first one, the second one, do you see this is quite same as whatever we have done earlier? You see that? You have to show these two are norm. We have done something for metric. Do you remember? We have to D1 and D infinity are metric. Now we are going to prove this norm x, norm 1 and norm infinity. And these are the standard notation. Huh? We are going to prove these are norms. These are the homework. Send me the solution. Hello.
Sir, can you send the notes?
Yes, yes, I'll send the notes. No issue. Prove this second one, and later on I am going to define one more norm, and we'll work with that also. Okay. Till that, whatever we have done, just revise it once again. Let us go slow, and tell me if you have any issue in the next class. Okay.
Yes, sir.
Is that clear? Am I going fast, or that is okay to you?
Sir, a little bit fast.
Okay, okay. So maybe from the next lecture, I'll try to go slow. You should have told me earlier. Thanks. Okay, anything else? Yes, anything else?
No,
So
sir.
maybe on Friday, we can review whatever we have done till now, correct? So revise whatever we have done. I'm going to ask some question, and you have to do. That means that there will be question. Something I give you a D1, I give you a metric and check whether it is a metric or not. I give some norm, check whether it is norm. Let us make a tutorial type lecture, correct? So that our concept will be much clear. Is that okay?
Yes, sir, sure.
Yeah. So just
Yes, sir.
revise whatever you have done. So we'll do that in the Friday class. Okay. Thank you so much. Bye.
Thank you, sir.
Bye. See you in the next class.